So here's an example for how to perform a significant test about P. So for example, arthritis is a painful chronic inflammation of the joints. An experiment on the side effects of pain relievers examined arthritis patients to find the proportion of patients who suffer side effects when using ibuprofen to relieve the pain. If more than 3% of users suffer side effects, the FDA will put a stronger warning label on packages of ibuprofen. An SRS of 440 subjects with chronic arthritis was selected and given ibuprofen for pain relief. 23 subjects suffered from adverse side effects. So remember that when we're doing this, we need to be able to use the four-step process. And remember that your four-step process is state, plan, do, and conclude. So your first step is to state what the problem is. Well, to state what the problem is, we want to perform a test of the null hypothesis where P equals 0.03, because that's what we're trying to find, up here where it says 3% of users. And the alternative hypothesis is P is greater than 0.03. And you also want to make sure you identify what P is, where P is the actual proportion of users of ibuprofen who suffer side effects. Okay, we're also going to use an alpha value of 0.05 for the significance level. Now remember, that was not told up in the problem originally, but if we're not told one, the alpha equals 0.05 is our go-to or your default level that you're going to want to use. Okay, so when you're doing your state, make sure you tell them you're going to perform a test of what your null hypothesis is, what your alternative hypothesis is, what your statistic or parameter is that you're going to be using. So here we're using a proportion, and then also what significance level you're going to use. So your plan, remember your plan, is that if conditions are met, we will do a one-sample z-test for the population proportion P. So the first condition to check, because in the plan piece you want to make sure you do your checking of conditions, is it random? Well, yes it is. The problem tells you up above that an SRS of 440 subjects was taken. Does the 10% condition met? So is 440 less than or equal to 10% of the population? So yes, it is reasonable to assume that there are at least 4,400 subjects that meet the criteria. And is the large counts condition met? So remember, you want to do n times p of the null hypothesis is greater than or equal to 10. So n, remember, is your sample size of, you have 440, times your p sub 0, which is your null parameter, which remember is going to be 0.03. We get that from up here where our null hypothesis of P equals 0.03, and we should get it's greater than or equal to 10. If you do out the calculations, you will find out that that is actually true. Okay, you do also have to do n times 1 minus P, the parameter, the null hypothesis of the parameter, excuse me, the null parameter. So then you also do 440 times 1 minus 0.03 must be greater than or equal to 10, and you're going to end up finding out that that is also true. Okay, so since all three conditions are met, we can now go forward with doing our plan, our test. So we're going to start by doing the do. When you're doing the do part, you have to first identify what your p-hat is. So remember, your p-hat is going to be your successes, or 23, over your sample size, which is going to simplify to about 0.0523. Okay, so after you find your p-hat, or your proportion here, you need to find your test statistic. When you're finding your test statistic, remember, it doesn't say test statistic exactly on your reference sheet, but you're essentially doing a z-score. It's on your reference sheet, but it's stated differently. So remember, you're doing z equals x minus mu over the standard deviation, except in this case we're going to have z, again, equals x, which is instead your p-hat, minus mu, in this case, is your null parameter, over the standard deviation. Okay, remember, we have to use the formula for standard deviation of a proportion, which is going to be p, the null parameter, times 1 minus that null parameter, over the sample size. Okay, so we substitute in. So you're going to have 0.0523 minus 0.03 all over P naught, which is 0.03 times 1 minus 0.03, all divided by 440. When you do all of that out in your calculator, which I have already done, you end up getting a z being of 2.74. Okay, so we have z equals 2.74, and it's a rounded value. You can now then go into your tables if you wanted to and pull out what is the area when z is 2.74. So here going across, the area when we have is 2.74 is right here. This is the zeros, ones, twos, threes, and fours. We have 0.9969. So the p-value, or the probability of when z is greater than 2.74 is going to be 1 minus that 0.9969, which is 0.0031. This is, remember, you're considered your p-value now. So we went through, we did out our calculations, and we get our p-value there. Okay, that's going to come into play again when we're looking at our, comparing it to our alpha value. So now, if we go through and we look at that, remember we have a p-value. We want to compare the p-value to your alpha value. And depending on what the relationship is there, whether it's greater than or equal to, or whether it's less than, is going to determine if you reject the null hypothesis or if you fail to reject the null hypothesis, which is what you end up stating in your conclude step. Okay, so remember, because the p-value of 0.0031 is less than alpha equals 0.05, we reject the null hypothesis. Okay, that's what we're always trying to basically prove. Do we reject it or do we fail to reject it? So you also want to include another statement that goes according to the problem or in context for this problem. So there is sufficient evidence to conclude that proportion of ibuprofen users who suffer adverse side effects is greater than 0.03. Now, you can also do this in the graphing calculator, but you need to be careful because you need to explain what exactly you do in the calculator for that step. Otherwise, they won't give you full credit for the do piece of your test. So to get to it, you can get stat. If you go over to here where it says tests, and if you look down here, there's a whole bunch of choices you can choose. If you choose the one prop z test, or 5, it's going to ask you for what your p-naught is. Well, we know that p-naught, remember, was 0.03. The x is going to be your value of successes, in this case 23. Your n is your sample size of 440. Now your proportion that you have to choose between it doesn't equal the p-naught, it is less than p-naught, or it is greater than p-naught. So in our case, we're choosing that we want it to be greater than, and then you scroll down, you can choose a different color. If you wanted to draw it, you could, and you want to click on calculate. It's now going to give you right here what the z value was, so you could write that on your paper. It's going to give you the p-value that we care about, which gives us the 0.003. So there is where the p-value would end up coming from if you wanted to just do it in one step on your calculator. Okay, so if you have further questions, come find me in the building. Thanks.